Look at this equation. 99% of students look at this logarithm, the complex number, and the power of 10 and immediately skip the question. They think it's a typing mistake on a Harvard exam. But what if I tell you that this terrifying monster is actually hiding a grade school secret? In the next 60 seconds, I am going to destroy this entire equation using nothing but a basic counting trick. Don't believe me? Watch this. Let's attack the scariest part first. The absolute value of 1 plus I to the power of 10. Ignore the power for a second. The absolute value of 1 plus I is just the square root of 1 squared plus 1 squared, which is the square root of 2. Now raise that to the power of 10. That is simply 2 to the power of 5, which gives us 32. Let's drop this back into the equation. Now we have log base x of 32 plus 23 equals 2, which simplifies perfectly to log base x of 55 equals 2. Now stop right here. What does this log actually mean? Think of exponents. We all know that 3 multiplied 5 times is 3 to the power of 5, which equals 243. Logarithm is just that exact same math, but asked backward. Instead of asking, what is 3 to the power of 5, log asks, to what power should we raise 3 to get 243? And the answer is 5. That's it. Log is not an operation. It is just a question hunting for a missing power. So let's ask that exact same question to our equation. Log base x of 55 equals 2. This literally means, to what power should we raise the base x to get 55? The answer is right there. The power is 2. This gives us the cleanest equation on Earth. X squared equals 55. Since a log base can never be negative, we take the positive root, and the final absolute answer uncoils beautifully. X equals the square root of 55. If this unlocked a new core memory for you, smash that subscribe button, and I'll see you in the next loop.